Okay, I think that this particular video is likely to be pretty short because I just don't love this particular topic. It's ideas of risk and life expectancy, and it's the life expectancy part that I don't love. So I tend to I show it and I make sure that everybody understands how our ideas of statistics and probability will fit in with some of this stuff. Insurance companies in particular are interested in what is risky behavior and what is life expectancy. For instance, if you ever fill out an insurance policy and request for an insurance policy, they're going to ask a whole bunch of questions about your lifestyle. Do you smoke? Why do they want to know that? Because if you're a smoker, then you have higher risk of catching certain diseases like lung disease, emphysema, things like that, right? So that one would probably count against you. If you applied for life insurance, you'd probably have to pay a higher premium and this kind of thing. Okay, so one that gets thrill seekers in trouble. Are you a skydiver? Okay, if you're jumping out of planes willingly, okay, then that carries, it's a relatively safe pastime, I understand that. However, it does carry some risk with it. So if you're a scuba diver, which I happen to be a scuba diver, if you are, that's a little more risky than always keeping your feet planted on the ground, right? So if you have one or two little risky behaviors, it might not be that big of a deal. Say you go scuba diving once every 5 years when you're in Cancun or something like that. Okay, fine. That's not quite so risky. But if you're somebody who goes out every other week to go diving off the coast of Galveston, and you're out where there's, ships out there and sharks and stuff like that, and huge waves, that's different than, if you're doing that every other weekend than somebody who just does it occasionally for recreation. So depending on your lifestyle, they may find you more at risk, and they may consider your life expectancy shorter than somebody else that's the same age as you are, same fitness level, that kind of stuff. What if you're overweight? Well, that puts more stress on your bones and your organs and stuff like that, so you might be at higher risk for certain diseases like diabetes or this or that, heart disease and stuff like that. So all of these things add up, and that's what we're going to talk about here a little bit, not a lot, okay? So just in general, what would you say if I told you the chances of someone dying in a car crash automobile accident is what it says, are 1 in 8,000. That's actually not as low as I would like it to be. That's a pretty good shot. I know Commerce has 8,000 people, so that one person in Commerce has a chance of dying. And I don't know how often, but that's just a number I was given. Now, this is figured out how. This is a relative frequency probability, okay? So what they've done is they've figured out how many people have crashed in cars and died, and give that out of a per capita, how many people in that city, state, town, country, whatever it was that they used to figure out this particular statistic. I don't know if this is even accurate or not, but just say that that's true. So you have a 1 in 8,000 chance. Okay, that doesn't comfort me very much, but here's the question. What are the odds? Let's say chances. What are the chances you will not die in an auto accident? Oh, well, now that is a little more comforting to me, because whenever I think about it that way, how can we use the statistics that we know so far? This is my chance of dying in a car crash. What's my chance of not dying? Well, all of that comes from out of 100%, right? So a 1 minus 1 out of 8,000. Well, we all know that's 8,000 out of 8,000 minus 1 out of 8,000. What is that? 7,999 out of 8,000. All right. That's a pretty good chance I'm not going to die in a car crash. All right, whenever you think about it that way. Okay, so it's 1 in 8,000. I'd rather it be, say, 1 in a million, but this is pretty good odds that that's not the way you're going to die, right? So take that. You can make that into a decimal or a percentage or whatever. Okay, so that might be something that they want to know. Okay. Sometimes they're going to try to figure out insurance policies and what to charge people. Okay, or if they sell certain insurance policies, will it even be worth it to them? Can they make money? All right, so let's think about this. And when we talk about this particular problem, let's say that we're looking at it from the insurance company point of view, not from the person who's buying it. Okay, they want to know if it's worth making any money off of them. Okay, so let's say we're trying to sell an insurance policy. We're the insurance company, and our policy is for serious illness. Now, you have to give people something so they'll buy your insurance policy. So let's say that if you get seriously ill and die, and we'll give them, certain list of illnesses like heart disease or cancer or whatever. So certain serious illnesses, we'll list them out. If you get that and you die from it, then we'll give you $100,000. Okay, it's a $100,000 life insurance policy. That's what we're saying. All right. Well, what if? And again, I don't love this number. 1 in 500 people who buy this insurance policy claim this benefit. Okay, 1 in 500. I don't love that. But it is 499 out of 500 who don't claim it. So what if 1 in 500 people claim this benefit? And you are the insurance policy holder, the company, and you want to know, can you sell these policies for $250 each and still make money? Okay, because if we don't sell these for enough money, if we have to pay out $100,000 to one person in every 500, then if we don't sell them for enough money, then we're not going to be able to stay in business, right? We'll be going bankrupt. So we want to make sure that however much we charge people for our policies, it's enough to cover what we know is going to be our expenses, which is that 1 in every 500 people is going to collect, right? That $100,000. So this is where our expected value comes into play that we've figured out, right? So let's go back and talk about that. There's the expected value was the probability of event 1 happening times the value of event 1 plus the probability of event 2 happening times the value of that event happening. What's it worth to us, and so on and so forth, depending on how many events I had, right? Remember we talked about that a couple of videos ago. Okay, so this is expected value. Well, let's think about it. All right, so let's just consider that I sell one policy. Okay, let me come back down here so we can see it. What if I sell one policy? Okay, I make automatically, I will earn this $250. Does everybody agree? Okay, so what's the probability of event 1 happening? I sell that policy. One policy. Well, that happens, right? That's a 1. Okay, so I sell a policy. And what's the value to me, the insurance company, for that? It's $250 in my pocket, right? That's a positive number because I'm earning, the person who's buying the policy gives me that $250, right? Okay. So that's a positive. Now, if I had sold 5 of these, then I'd do 5 and so on. I'm just trying to figure out for one person, is it worth it? And then you can do relativity for how many policies I'm going to sell. What if I sold 10 million policies? What if I sold 1,000 policies and so on? Okay, so for one person, I sell them one policy, it's $250. What's the probability, event 2, so I'm making money here, but here the probability plus, what's the probability that I have to pay out my $100,000? Well, that's this probability right here, right? 1 in 500? Okay. So 1 out of 500 times I will have to pay out. Okay, so we got to watch out for that. Okay. What's the value of that particular event happening? If 1 in 500 people. The value for me, the insurance company, be careful, it's not the person buying it. The insurance company would have to pay $1 million or $100,000, right? Is that a positive or negative for me, the insurance company? For me, the insurance company, that's negative. That's money going out. Okay, so this is the event where that one person out of 500 gets sick. I'm going to have to pay. Okay, this is the serious illness policy. That's what we're talking about. All right, so what's this value right here? Event 1, I sold the policy, $250, right? That's a positive. What's going on over here? Let's do some reducing as much as I can. Well, the 0, 0 on the bottom with the 0, 0 on the top, those go away. A positive and a negative is a negative. So what I've got, this is all over 1, right? What I've got is a negative 1,000. 1,000 over 5. Is that okay? Once I reduce things down? Okay. Well, what's 1,000 over 5? 200, right? $250 I received for every person. It's an average expected value of $200 going out of my pocket per person. That would be a positive, whenever I make this subtraction, $50 per policy. So if I only have to pay out 1 per 500, okay, then per person I should be making $50 on these policies, right? Now, that doesn't sound like a lot, but how do these insurance companies get by, right? What if they sell 1,000 policies? Okay. Well, if they sell 1,000 policies times $250, that's $250,000, right? That they're selling, that they're bringing in because they sold those policies. But if it's 1,000 policies, they would expect, there's that expect word again, they expect to pay out twice, right? 1 per 500 people, so they expect to pay out twice. So 100,000, 100,000. So they expect to pay out $200,000. Well, this guy looks a little bit different in the math, right? 250,000 minus $200,000 that they would have to pay out. That looks like they're making $50,000. So if they sold 1,000 of those policies, and think about how big some companies are, like State Farm or Allstate or whatever, they're making off of these 1,000 policies $50,000. So it may be $50 per person, but the expected value per 1,000 policies is $50,000. So that's how they manage to stay in business, even if they're offering a relatively high payout. Everybody goes, oh, how can they afford to pay that? Well, it's because they're getting maybe a small amount, but from a lot of people. That's what's going on there. Okay, so that's kind of some of the stuff that might happen from insurance policy perspective. They've got, if you're interested in it, they've got actuaries who do all kinds of statistics for them and figure out what's that probability that so-and-so with these conditions and these health conditions and this lifestyle and blah, blah, blah. What's the probability that person's going to die in a car wreck or whatever? And then based on that risk assessment, that's what it's called, they use a risk assessment on each of these people, then they'll sell you, and your insurance policy might not look like my insurance policy, right? So if you're 20 years younger than me, let's just face it, I'm closer to dying than you are. So the odds of me dying are going up, the chances of that happening are going up. And so they go, oh, we're going to raise your premium. They do that sometimes, right? So actuaries are the people, the stats people, so to speak, that figure that stuff out and figure out how much they should be charging everyday people. That's why not everybody's insurance policy looks like everybody else's. Okay. All right. Risk and life expectancy. So here's a lovely graph. I like to throw this in from time to time. This particular graph is one of those graphs that's maybe a little bit difficult to read. Automobile fatalities and vehicle miles driven in the United States. Okay, and you might not be able to read all of this. This says 1970, which is before I was born. In 1970, automobile accident deaths that year were over 50,000 in the U.S., all of the U.S., okay? If you follow these bars, there's a little bit of dip down here in the 70s, okay? Then it goes back up, and there's a little bit of a dip in the 80s, and it goes back up, and then it comes down. These bars, whenever you get way over here, they're only, and this is 2015, so this is relatively recent, they're around 30, maybe 35,000. So they dropped from over 50,000 to over 30,000. So there's around 20,000 fewer deaths per year at this point. So that's one of the pieces of information that's on this graph. The other piece is the vehicle miles driven. So this is what I find interesting. The number of deaths in the U.S. from car crashes is going down. We can see that. But look here, the blue line represents vehicle miles driven, which is given on the right axis. So in 1970, let's come over here and see what this is, 1.2 million miles per year is what the U.S. people were driving, okay? And I remember whenever I was a kid, you didn't just drive to Dallas just because you wanted to go to Dallas tonight. Like, it was an ordeal. And if you wanted to go see your aunt, then we loaded up in the car and we were gone for 2 or 3 days. You didn't just drive to Dallas and pop in for dinner and come back. It was a big thing. And part of that was because gas prices were high compared to people's salaries, and part of that was just because people just did not drive. Like, you would have stayed, if you lived in Commerce, you would have stayed primarily in Commerce. Like, even a trip to Greenville, you would want a reason to go to Greenville. You didn't just drive over there to go to Applebee's or something. No IHOP trips for you, okay? So 1.2 million miles in the U.S. driven in 1970. So if I follow this blue line in 2015, it's over 3 million. So not quite, but getting close to 3 times as many miles driven in the U.S. So what I see here is the number of deaths is gradually coming down, and the number of miles is gradually going up. And you see a few dips here and there and different things. I would say probably some of these dips are from maybe people not being here because of the Vietnam War. Maybe this could be because this is when they enacted seat belts. Children had to be in car seats. 2008, probably there were more passive airbags, different things happening at different points that make travel better and more safe in the car. So putting in seat belts, making people wear them, putting in car seats for kids, making the car seats be used, airbags that automatically deploy, side airbags, curtain airbags, all kinds of stuff going on that makes our cars safer nowadays. So the question becomes, so are we safer now than before? And yeah, you can do actually they've done it here, so I'm not going to do it. You can do an analysis. In 1970, they said there were 52,000 deaths for this many miles driven, which is 0.00052 deaths per mile. Okay. 2015, it's only 34,000 deaths for this many million miles, which is 0.11. So they're saying 5 deaths per 100 million here in 1970. And per 100 million miles driven in 2015, it's only 1.1. Okay, so it's about a fifth almost as many deaths. So that's nice to know. Even though we're driving more, it's actually safer. So some questions come up. Is it safer to fly or to drive? Some people worry about flying, right? They get nervous about flying because they feel like, I think, they're not in control, right? If I can't do anything if this plane starts to crash. I can't steer it, I can't stop it, I can't do anything. So some people are a little bit nervous about that. But what about like deaths per accident or whatever? So, and truth be known, if a plane goes down and you're on it, you probably don't stand much chance, right? But the question becomes, which is safer, driving or flying? Okay, and again, I don't love these topics because I don't love the death topic, but there's risk involved with travel, right? Let's just face it. A lot of us like to travel, but a lot of us have to also acknowledge the risk. So here are flying statistics. This is what we need to know. On average. Okay, and again, that would be a mean. So see how all of our statistics is coming together. There are 60 deaths per year. Per year involving aircrafts. Okay, so let's think about that for just a minute. On average. How is that possible? If a big plane goes down, there might be 300 people on that plane. So how is this possible? Because it's on average, right? There are years when there aren't any commercial planes that crash. Maybe it's just one or two private planes that would crash on an average year. Okay, so the big commercial plane falling from the sky or getting having engine trouble or whatever that you hear about, that actually is pretty rare. Okay, when you think about it, you don't hear about them all that often. So what they do is they take all of the deaths from aircraft crashes and they average those over time. So look at a 10-year period. How many deaths were there? Divide by 10. Okay, so that's what they mean by the on average part. It's a mean. It's an average. Okay, so there's a statistic. Here's another statistic for us. Airplanes fly approximately, so I do the squiggly equals, approximately 8 billion miles per year. Okay, 8 billion miles per year. Okay, now this is a huge number, right? And we can automatically tell, hey, only 60 deaths per year and 8 billion miles. Now this is not just in the U.S., but we just saw in 2015 in the U.S. there was like 32,000 or 35,000 deaths just from flying, right? In 2015, in 1 year, okay? There is only 60 on average per year in the world, okay, here. So you can see that there's a difference there, right? Okay. What is this death per year or death per mile wise? It's 60 out of 8 billion, which is 9 zeros. Okay. So if you wanted to divide that out, it would be 0, 0, 0, 0, 0, 0, 0, 0, so 8 zeros, 7, 5. Okay. So you might hear people say that this is per this many people or whatever. If a lot of times statisticians like to give numbers like that, so they might move this decimal 1, 2, let's see, 3, 4, 5. If they wanted 100,000 people, they might say per 100,000 people, this is 0.00075. Okay. Deaths. Okay. So sometimes they'll try to put that in terms of how many people, and the primary reason I think they do that. Okay, so this is less than 1 death per 100,000 people. Just think about that. It's relatively low. But the reason I think they do that, this decimal right here with 8 zeros and 75 at the end, it's very difficult for somebody to kind of wrap their brain around how small that is per mile flown. And then you'd say, well, let's see, it's 1,000 miles, say, from here to Chicago, so it's probably not that far, but however far it is from here to Chicago, I'm going to make that trip once. How much is that? What's my risk of dying for that trip to Chicago and back, that kind of thing. So sometimes they'll say per person or per 100,000 people, and so there's only 0.00075 deaths per 100,000 people. That's very few, right? So no big deal. Flying is actually much safer. Okay. Yeah, I'm not going to do a ton more with this, the death thing for sure. I want to talk about 2 things real quickly, also involving risk. Okay, actually they're both about gambling. I know. There's a lot of gambling that goes on, or a lot of statistics that goes on in gambling, I should say, basically. Okay, so let's talk just a tiny bit. I remember in my very first stats class that I ever took, my stats teacher talked about the lottery, and back then he said the lottery was slightly different back then. There's a lottery where you choose 6 numbers between 1 and 50. 1 and 50, okay? And you try to match those and all kinds of stuff. And I recall that my stats teacher back then said, if I ever play, he said, I'm never playing the lottery because the odds are so far against you. But he said, if I ever play, I'm going to pick 1, 2, 3, 4, 5, and 6. Those are his lucky numbers. That's what he said in that class. Okay? And I just thought, well, that's crazy. Okay, and he said, am I being foolish? Why or why not? Okay, so let's think about this for a second. If he ever plays, then he's going to pick those numbers. Okay, so let's think about this. It's a lottery with 6 numbers, so you're going to pick 6 numbers. So let me just make like boxes here. First number, second number, third number, fourth number, fifth number, and 6th number. My boxes are getting smaller because I'm running out of space. Okay, there we go. All right, so what is you're spinning the little thing like a bingo wheel, right? And one of the little ping pong balls comes out. What's the probability that one of the numbers that comes out is the 1? Well, there's 1 in there, right? And there are how many choices? 50. Okay. And think about it. What happens once the 1 comes out? Is it still in there? No. So is this independent or dependent? The next probability here for the second number. is dependent on what happened on the first one, right? Okay. So what if the probability, or what if this first one was not the 1? Well, what's the probability that it'll be a 1 here? Because it doesn't have to be in this order, by the way, right? Order doesn't matter at all, so we don't care about that. Well, there's still 1, 1 in there, but how many balls are in the thing now? Only 49, right? Because one of them came out, and we don't put that ball back in there. It's gone. Not replacing, right? So this is a dependent situation. Well, once I pull this second ball out, say it was the 5 or something, what's the probability that this one is going to be the 1? Well, it's only 1 out of 48, right? And so it goes. There's only one option for this box. Now there's only 47 balls in there. There's only one option for this box. Now it's only 46. And there's only one option for here. It's 45. So if this was the 1, this was the 2, this was the 3, so on and so forth, whatever, it doesn't matter. Order doesn't matter at all. But there's only one of each of those in there, right? And as I pull a ball out, the number on the bottom goes down. So you would what? I want this one and this one and this one. So I would multiply, right? This is an and situation, an intersection, so we are going to multiply. So he said, am I crazy for doing this or what? And I said, well, I wouldn't do that. You know, my favorite numbers that I would pick would be like 4 and 28 and blah, blah, blah. And he's like, well, why? And I'm like, well, those are important dates to me. No particular reason. Just those would be my, quote, lucky numbers. You know, those are the numbers I'm going to pick. I'm trying not to end on life and death situations here. I'm trying to talk about gambling because it's a little more fun than risk assessment and stuff. So he said, well, let's see your probability. That's what he said. Well, what's the probability that you pick a 4? Well, 1 out of 50. Okay. What's the probability of your other number? It was a 28. And I said, well, it's once I pull that 4 out, it's 1 out of 49. And he said, what's the probability for your next one after those 2 balls are gone? Well, it's 1 out of 48. And the next one's 1 out of 47, and the next one's 1 out of 46, and the next one's 1 out of 45, which is exactly what his probability was. And he said, so your probability for your random numbers that mean something to you is the same as my probability for 6 consecutive numbers. So his probability is absolutely just as likely as my probability. So whenever he looked at that, he said, so why am I crazy for picking consecutive numbers? The probability is the same. And the answer is he's not. Every once in a while, you might see 2 or 3 numbers in a row on when they call out the lottery numbers, right? It's just unusual. It doesn't normally happen. We don't see it, right? And why is that? Because what is this probability? It's like 1 in, I don't know, 1,000,000 or billion or whatever that is. I don't know how big that is. But it's a very, very big number. So when will you see 1, 2, 3, 4, 5, 6? Not very often. Only one time out of whatever this number is down here when you multiply it. So it doesn't happen very often. But then again, my numbers don't happen there that often either. 4 and 28 and 29 and all my other numbers, I'm not giving them to you because I don't want you to use them. That's my lottery numbers. I never play. But anyway, so it's just a matter of our personal preference, right? But he was saying the probability, mathematically speaking, statistically speaking, it does not matter. This 1, 2, 3, 4, 5, 6 is just as likely to happen as any other 6 random numbers between 1 and 50, okay? The difference is whether or not you really think that your combination is lucky numbers or not. Okay, and that will end me up with one more thing, and it's also about gambling. There's something that we talk about from time to time. It's called a gambler's fallacy. Okay, and this kind of ties in with what I just talked about with the lottery. You'll hear people saying, oh, I can't quit now, I'm on a roll. I'm on a lucky streak, right? Okay, you'll hear people say that. Or sometimes you'll hear, my luck has been so bad I'm due for a break. Due for a break. Like they deserve it. Okay, I deserve a break, dang it. I've been sitting here at this slot machine all day. I haven't won anything off of it. I've put $300 into it. Ooh, that would hurt my heart, by the way. Dr. Webster is not a gambler at heart. I worked hard for my money, and I don't like just spending it. If you say that's your entertainment value for the night, okay, but I don't normally go and spend $300 on a movie, so I'm unlikely to spend $300 sitting at a slot machine. It's just my personal opinion. That would really hurt my heart to see somebody do that. I have seen people do it, so whew, glad it's their money, not mine. Okay, but this idea here, you've probably heard that before if you've ever talked to anybody about going to a casino in Oklahoma or Shreveport or something like that. Okay, you might have even said it yourself. Okay, so here's where the fallacy comes in, and hopefully when you see fallacy, you know that fallacy means false. Fallacy means false. Okay, so it may be a belief, but it's not true statistically speaking. Okay, and here's what it says. The gambler thinks that if they are losing, they should hang in there, keep playing, because they are due for a win. Their luck is about to change. Okay, that's the idea behind the gambler's fallacy. And unfortunately, this is why a lot of people spend a lot of money on gambling and lose a lot of money on gambling whenever they sometimes can't afford to lose that money. It's not really their entertainment money. It might have been rent money, and that's unfortunate. Okay? So the question is, why is this false? And I hope, with all of the probability that we've done, and we're wrapping up, and hopefully you've thought about this, I hope you understand that the probability of winning on whatever machine that is, or whatever game of chance that is, it doesn't change, right? This thought is about luck, right? Maybe some people believe in luck, and that's okay, but the probabilities, let me say that, of games of chance are mathematical, right? We can count them. We can count how many ways you can win, and we can count how many ways or total outcomes there are, and they don't change. Okay? The probability of winning at a certain game is the same when the gambler sits down as after he's been there. For hours. Okay, so say we're talking about roulette, right? We've talked about that before. There are 18 reds. So let's just put this example. Roulette, the probability of a black hitting on a black is 18 I said reds, but I'm going to do black because that's what I wrote. I don't know why. Out of 38, right? When he sits down to play this game, it's 18 out of 38. And when he's been sitting there for 2 or 3 hours, it's still 18 out of 38. The probability of winning on a black. Okay, now, or a red, it's actually the same for red. It doesn't matter which one you pick. Okay, they're both 18 out of 38. Less than 50%. It was like 42%, right? So that probability, that chance of winning does not change, and it's just as likely to win now as he was before. Okay, just as likely to win at any time. So he's not due for a win. It's not necessarily that his luck's going to change. The probability is what the probability is, and it's not going to alter just because he's been sitting there for 2 or 3 hours and he feels like it's his turn. It's my turn to win. Come on, help me out. So just be aware that that's not necessarily going to happen. All right. That's it. There is some other stuff about your life expectancy. Should you expect to live to be 110 and stuff like that? And of course, hopefully by now you can figure out that the way that the life insurance people figure out if I'm going to live to be 110 is by looking at all of my lifestyle habits, looking at my genetics, looking at do I live in a big city or a small town, things like that, and figuring out how many people in that area where I live have lived to be 110, and then figuring out my probability of making it to be 110. So same as stuff we've been doing. I don't feel like I need to do that example. If you have questions about any of that, let me know. Otherwise, have a great day. Thanks.